Okay, this lesson is on graphing parabolas that go left and right. Okay, unlike parabolas that go up and down parabolas are actual functions, which means that you could use your graphing calculator to do a lot of this stuff and find a lot of the points that way. Unfortunately, with left and right parabolas, they're not actually functions. So in order to graph them, you're going to need to use Desmos. Now, Desmos, just like before, Desmos will only give you the graph, like the vertex and maybe x-intercepts, y-intercepts, but it will not give you the focus or the directrix. So, and it does follow a very similar formula, as you can see here with the vertex formula. Everything other than the A, everything's just flipped. So you have, the X and the Y are flipped spots. The H and the K have been flipped spots. But the A remains there. One thing to understand is that the vertex doesn't change. It's still HK, it's just now the H is over here and the K is over here. So when we go to find all the information, you're going to do exactly what you did in the last lesson. You're just going to have a sideways parabola because the focus and the directrix and everything like that are horizontal. As you can see in the picture here, you might find the vertex and you might find the p-value, and you have to understand that with the way that the formula is, you have to know that you're going left and right. So before, with vertical parabolas, you had y equals something x squared. So this tells you right here, the fact that it's x equals, you're going to have a horizontal parabola, a parabola that goes left and right. So you're going to find the same pieces of information you did before, find your p, and then the difference here is that you're just going to go left and right instead of up and down. So let's do exactly what we did last time. So given this equation right here, we have our A. Now by now you should have figured out that when there's nothing else here, it means that your vertex is at 0, 0. So, and if you put that into by the way, and if you put this into Desmos, you'll see that your vertex is at 0, 0. I know last lesson we went through and we put parentheses, we completed the square to get it into vertex form. But the reality is, you can just use Desmos to find the vertex to see where your starting point is. If you put that into Desmos, you'll see that your starting point is at 0, 0. So we're going to do 0, 0 is my starting point. There we go. And now we just need to find the value of p. And remember, none of this is different. So p equals 1 over 4a. Here's my a right here. So that's 1 over 4 times negative 1/8. Remember that you do the bottom part first. You do 4 times negative 1 divided by 8, in which you'll get negative 0.5, and then you do 1 divided by that, and you get negative 2. Now, what that means, in vertical parabolas, that meant that the parabola went down. Because we're talking about left and right parabolas, the negative direction is left. So that tells you that it's going to go left 2. So we go left 2, and remember that always tells us where our focus is. That means that our directrix is the exact opposite, at right 2, and that is now a vertical line instead of a horizontal line. So we're almost there. Now, here's where it gets a little tricky because your graphing calculator could tell you points in which you would graph this, but my recommendation is just use Desmos. Just use Desmos and find a couple points here. What you would find is negative 2, 4 is one of them, and negative 2, negative 4 is another point. And then just graph it. And that's it. So that's horizontal parabolas. Again, essentially it's the same thing. It's literally the same thing as before. The only difference is because you have an x and y, x equals, it's going to be left and right instead of up and down. So we can try this one. So again, there's nothing over here, so it's 0, 0, but you could just put x equals 1/4 y squared into Desmos, and you would see that the vertex is at 0, 0 there too. So 0, 0 is the vertex. We'll do this one in maybe blue. So the vertex is at 0, 0, and then we need to find our p-value. So p equals 1/4a, and then so 1/4 times 1/4. Well, 1/4 of 4 is 1, so 1/1 is 1. Because it's positive, and this is a left-right parabola, we know we're going to go to the right one for our focus. So it's right here is your focus. This is the vertex, which means that the directrix is 1 left. So this is the directrix, and that will be a vertical line. And then we resort to Desmos to finish it off. But basically, if you put that into Desmos, one of your points you should see, or one of the points you would get is at 1, 2, and 1, -2. So your parabola goes something like that. So that's horizontal parabolas, and just like with vertical parabolas, we can go backwards. So here's an example where they give you that the vertex is at the origin. So a couple pieces of information. The vertex is at the origin, and your directrix is at 8. So what that means is that our vertex is at 0, 0, and our directrix is at 8. So because our things at the origin and our directrix is at x equals 8, we know we're going to have a horizontal parabola. So, and if you don't believe me, I mean, you could just sort of draw a fake graph here, put a point at 0, 0, and then put a line at x equals 8. So you know that this is, first of all, you know that it's horizontal, and second of all, because it can't go towards the directrix, you know that this is going to go to the left. So we're going to use the horizontal parabola formula, which I already messed up. X equals a, and that's y minus k squared plus h. And all you do is sort of plug things in. The vertex is 0, 0, so I know that I'm going to have x equals a y minus 0 squared plus 0. So all I need to do is find the a, and that's where that other version of the formula comes in, where a equals 1/4 p. P, if you remember from the last lesson, P is the distance between your vertex and either directrix or vertex. So because it's at 0, 0 and the directrix is at 8, the distance is 8. So this is 1/4 times 8, or your A value is 1/32. Now we do have to keep in mind that the parabola is going left. We found that out right here. So it's negative 1/32. So my final answer is x equals negative 1/32 y minus 0 squared plus 0. And that's how you go backwards. That's it with horizontal parabolas. There are some more examples on the next page. You can do some more of these examples, but I went over all the types of problems you'll see on a test or a quiz. So that's it. You can do these for practice if you want to, and check your answers with me. Otherwise, try some on big ideas and see where you're at. Thanks.